Yeah, that contains all the cities in San Joaquin County, contains all the cities in Sacramento County.
Sections of this chapter
So I'd say the universal set is like an all-encompassing set.
Definitions and symbols, all that kind
Am I
of
going to
stuff.
spell encompassing right? Don't make fun of me if I spell it wrong.
Problems where we're solving things. We're actually
Contains all elements, it contains all the elements and all the sets that you're talking about. Maybe some extra, too.
I've actually seen Venn diagrams before. I've actually seen some memes of Venn diagrams. Where it'll say, like, here is a set of all, I don't know, is it my time?
Yeah.
I don't know. The time I have in
So yeah, notice, like I said, the universal set, it could have more elements than you really need, like sets A, B, and C. They only contain the cities that are in San Joaquin County, Sacramento, and Stanislaus. But U contains all the cities in the entire state. So there are some cities in the state that aren't in those counties, right? So it's okay for the universal set to contain elements that the sets that you're talking about don't contain.
No big deal.
Very confusing. Sorry. What do we have here?
Beginning, we'll talk about all the definitions.
First example. Let's just jump into it. This sections. I mean, once you kind of understand the definitions, it's okay. Some problems are kind of difficult, but let's see. They want us to determine if each set below is well defined. So remember, well defined. That means. What does that mean? It means not opinion based. Yeah, like we said above. It's just kind of like the race. There were 10 men in a race. It's not like I can say, oh, I think this guy won the race, and you can say, I think that guy won the race. I mean, I guess there are close races, but imagine it's not a close race. It's just, there's first place, second place. There's no opinions involved. It's either you won first place or you won second place. Yeah. But it's not well defined if it's opinion based. And then infinite, of course, I think we know what that means. That means there's no end to the set. But finite means there is an end. There's a finite number of elements. So part A says the set of best movies in 2010. Is that well defined? I'd say no, not well defined. Because that's opinion.
I should have added in that definition.
The best movies that I thought of this year might be definitely different than someone else's idea of best movies, so that's not well defined. Is it infinite? No. Oh, I would say finite. I was going to say not infinite, but you might as well say finite. It's finite because there are only a finite number of movies in 2017 altogether, right? There weren't an infinite number of movies, so my best movies are definitely finite. How about part B? A set of odd natural numbers. Well, that is well defined.
I'm about to draw all the elements in set B, but since they have none in common, I better make sure that these circles don't intersect. Because if they intersect, that means they have something in common. Since the intersection
well defined, is it
both A and B
infinite?
At the same time.
Yes, this odd natural numbers.
That's an example of Venn
1,
diagram.
3, 5, 7
sets that are
goes on and on and on. It never ends, so it'd be infinite.
And then just below that, just to make sure we understand it, they want us
How about
to draw
part
a
C?
Venn diagram
Part C,
for
the set of fastest running backs in the NFL.
So meaning they do have something in
So that one, I'd say it's not well defined. Well, or is it well
It's
defined?
just kind of a visual. Just imagine
The fastest,
everything in
an
set
opinion,
A.
no.
We don't even know what's in
Yeah,
there.
fastest is
Imagine
not an
everything in
opinion,
set
so
A
yeah,
is
it's well
a circle.
defined. I'm sorry.
And then set
I guess if I
B,
had
and then
said
draw
the
circles
best
for A,
running
B.
back of the
But since
NFL,
they said it's not,
then it would not be
they're
well
not
defined,
destroyed,
because I might
you
think
have
this
something in
running
common.
back's the
So I
best,
better
you might
draw
think a
some kind of
different one.
intersection here. And this represents what
But yeah,
A
since
and
it's
B
the
have in
fastest,
common.
that's actually something you can
And I'm
measure.
kinda-
You know,
it's
you
just kind
can
of general. I'm not
time
sure how
someone
big
when
to
they're
make
running or
intersections. I don't know
whatever
how
it
much
is.
they
So
have in
that's well
common.
defined.
Just kind of a
Is it
visual
infinite? No, it's
representation of
finite.
these sets. If they have something
There are only
in
a
common,
finite number of
then
running
they're
backs in the
not disjoint
NFL,
like
so the
here.
fastest one's
And if they
definitely
don't have
finite.
anything in common, then they are disjoint.
And then we got
Like
the set
you
of
see in
smartest
this
people
diagram
who
we
ever
drew
lived.
earlier.
Okay, that one actually is kind of tough. Do you think that's well
Draw one more
defined?
subset, or sorry, one more
I'd
Venn
say
diagram
probably
just for
not
fun.
well defined.
What do we have?
Because I think smart is different for everyone. You know, some people equate smart with good memory.
So I guess
Like
it
if you
doesn't
have a
matter
good
which
memory,
way,
you
but
probably do well in school
set A
because you
is
can
a
memorize
subset
all the
of set B.
material and you get good
That
grades.
means, as we saw in
But
the
I don't know if that
definition of the
necessarily
previous
means you're
section,
smart,
that
right?
everything that's in
I know there's all
set A is
kinds
also in
of
set B.
intelligence, so
So I could probably draw
could
set
be,
B
yeah,
here.
that you have kind of a street
Set A
smarts
should
where
be
it's,
entirely
you just have an
within
instinct
set
for
B.
things
So
and
it
you
should
kind of
be some
know,
kinda- as long as the
yeah, you
circle
just
set-
kind of know
circle
things.
of A is
You
within
don't have to
the
read them in
circle
a
of
book.
B. So if there was some part
But
of
then
A
there's
that
also,
wasn't-
you have a good memory,
that means
right?
A is
Like
not
you
a
said, then you
subset
get
of
good
B.
grades in
That
school.
would represent elements
And then
that are
there's
not
kind
in
of
B.
people that are just good with logic. Like in the
These are
last
kind of
chapter,
three
if you were
general
good at all those
Venn
problems,
diagrams
you're smart in a
Disjoint
different
sets
way.
here.
So I'd say it's not well defined
Not
because everybody's
disjoint
idea of
here.
smart is different. And I don't know if I can say, oh, this, you know,
And
say
this is
Einstein is the
subset.
smartest person who ever
You
lived.
could have drawn it the other way.
But is he
where
really?
B
That
was
might be
inside
my
A, because
opinion.
they didn't really specify which one they
That one
wanted.
seems well defined, but I don't know. I don't think it is. And then is it infinite? No.
What else?
There's only a finite number of people that live. So there's definitely only a finite number that's not. Yeah, it's not an opinion. I can't. I can't say no. I'm taller than you, and you say no. I'm taller than you.
So remember, we talked
One of
about
us is right, and one of us is
universal
wrong.
sets
That's not really an opinion
The
thing.
universal set is
So
just
that is
the
well
huge set
defined,
that contains
and it's
everything we
finite
talked
because
about. So I
you know,
guess with
there are only a
then there's
finite
an
number of
example
people
where
who
you're
ever
talking about
live.
a few different sets, like set A,
All right, how about this last
set
one
B,
here? The set.
and maybe another set.
Got the numbers
of those.
1, 4,
The
9,
universal
16,
set, it should be
on
a
and on
big
and on.
set that contains everything.
It doesn't ask
that
us
you're
this, but
talking
notice
about.
that these are
Everything in
the
set A,
numbers that are
set B,
squares. This is 1
everything in every
squared,
set you're discussing,
or
and
1 to
then
the second
maybe
power.
more.
This is 2 squared, or 2 to the
Universal
second
set,
power,
okay.
3 to the second
So
power,
again, the
9,
complement
4 to
of
the
set
second
A,
power, 16.
it's all the elements
So this
in
is
the
just
universal set
you're
that are
taking
not
the
in
numbers
set A.
1, 2, 3, 4, 5,
Yeah, that
6,
kinda makes
on
sense.
and
The
on
word
and on,
complement.
and you're raising them to the
What are all
second
the things
power
that
and
are
getting
not in
these
set A,
numbers.
basically. And symbolically, you use this.
So that's
kind
that
of a
set.
dash
Is it
over
well defined?
apostrophe.
Yes.
If you see A,
In math, it's hard to find something that's not well defined. I think that's why I
You're
like
talking
math.
about this, everything that's
There's
not
no
in A,
opinions. There's no. I don't know.
Yeah,
There's
I don't
nothing to
know.
argue
Especially
about.
if
You're
you
either
wanna
right or
write
you're
down
wrong.
everything.
There's nothing.
Well, the word that
Anyway,
we use is
I think that's
complement,
interesting.
But if you want to kind of remember what it means.
But it is well
We were
defined. There's
talking
no
about everything
opinions
not in
about
set
it,
A.
and it's infinite. So you can just tell by that dot dot dot.
And then what else does it say?
Yeah, that
The Venn
means
diagram
infinite. It's
is
going on
what,
forever.
Well, usually, I guess the
So I hope that one made sense. Those are pretty good
We
problems,
didn't really
right?
draw the universal set, but if you're
Let's
discussing
see. What about
universal
example
set,
2?
usually you draw
What do we got going
some
on
kind of
there?
rectangle to illustrate that's the universal set. That contains
Example
everything.
2, let's see, we're going
And
to
then any
express each of the
sets that you're
following
gonna
sets in
discuss
roster
will
form.
be
So remember,
circled
roster
within
form
that
was where you
universal set somewhere.
list all the elements
So like,
explicitly.
this time we're only talking about one set. I'll just draw one circle A.
Oh, that should be
and then
pretty
we'll,
easy, the roster form. You just say, alright, what the heck is in here?
Shade
Let me
in what
list
we're
everything.
what we're interested in here.
So how
We're
about part
interested in
A? The
complement.
set of months whose name
So I'm
begins
looking
with
at
the
this
letter
diagram
M.
and I want to know
Okay,
where
so
are
I'm
all
just
the
going to
things
create
that
my
are,
little
that are in the
squiggly brackets
universal
here.
set, but they're not in the set
And
A.
think about all the months of the year.
Well, pretty much
January,
everything
February,
within this
March. Okay,
rectangle,
there's
but
one that
outside
starts with
A.
M.
So anything in this
April,
rectangle
May,
is in the universal set, but it's
June,
not,
July,
if it's not
August,
in A, or
September,
it's not in the
October,
circle,
November, December. I guess
then it's
that's
not
it.
in set A.
I might have made those sets too wide, huh?
That's,
I
yeah,
could
as
just
you get more
end them a
complicated,
little
we'll
earlier
have
there.
to shade in the parts
There we
that
go,
we're
so that's
interested
it.
in.
And in a set, if
This
you're
is
not really
the
familiar from
representation
algebra,
of the complement of a set.
between the elements you put a little comma if you're
Alright, what
putting them in
else?
roster form. So March is
Then
one,
the
comma,
next
May
thing.
is another. If there were more
The
elements, I'd put a
intersection
comma
of sets
between
A and
them.
B. It's
And I
all
think that
elements
looks good.
common to A and B.
So how about part B? This
Symbolically, you
says,
might have seen this in the algebra
it's
class.
in the set
intersection
builder notation. This
symbol
is the
kind of
set
an upside down U shape.
of all
And yeah, you should have seen that in
x.
some
I'm
kind of
imagining
algebra
x is a
class.
number such that, that's what that vertical bar means,
Okay.
x minus
I'm gonna
5
draw two
equals 11.
circles, A and B.
So how many numbers have that
And I guess,
property
you know,
where
if
x
you're not
minus
sure
5
if
is
they're
11?
disjoint or not, because no one said in this
Well, I don't think very
problem
many,
whether
because I
they're
can
disjoint or
solve
not.
this equation to
I would just
figure
draw
out
them with
exactly
some
what
kind
x
of
is if I
open.
add 5 to the other
Here's the universal
side.
set. Here's
X is
set
16,
A,
so there's only one right answer here.
and set B. I don't know how
So
much
A would be
overlap
the
they
set
have, but
with only 16
since we didn't
because
discuss whether
16
they
is the only
have,
solution to that equation.
whether
There's
they're
nothing else you can
disjoint or
put in
not,
here
I'm
for
just gonna
x
draw
that
them
would
with
make
the
that
overlap.
true.
And then I'm
That's
gonna
kind of a
shade
weird
in
one.
what they have in common. So that's the
How about part C, the
intersection.
set
All
of...
the things that are in A.
I don't know why I said the
That
set of
shaded portion is
set.
in
Sorry.
A, but it's also in
The
B.
set
But that's
of...
the only part of this
cross the
diagram that's both in A and B
couple
at the
words
same
out.
time.
Professors at MJC who are
What
less
else is
than
there?
10 years
Yeah, you
old.
wanna know the
Okay,
union. That's another
so...
thing you probably saw in algebra.
I'm pretty sure, I'm not exactly
The
sure,
union
but
of
I'm
two
pretty
sets,
sure
it's a set
there
of
are
all
no
elements in
professors
A
at MJC that are less
and
than
all
10 years
elements in
old.
B combined.
So the answer would be the empty
And
set,
the
like
symbol
that,
for
or
it
you
is
can
the
write
right
this
side
down.
up view. So it's hard to keep track of.
Yeah, I guess if they had said
Right
greater
side
than
up
10
view,
years old, I would list
intersection is
all the
upside down.
professors, but less than 10 years
And then
old,
the
I
Venn
don't think
diagram
that's
looks
allowed. I
like,
think
let's
you have to
see.
be an
So I
adult to
started out
teach
the same
or
as
to
I
have
did in the
this
last
kind
one,
of
but I'm just
job.
going to shade in a different portion just to say.
Alright, how about part
Alright,
D?
this is-
The
it's
set of all
the
x
same.
such that
Here's the
x is a
universal
natural
set.
number. So we're only
Here's
looking at the
set
numbers
A,
1,
I don't
2,
know how
3,
big
4,
the
5,
circle
6,
should
on
be.
and on.
Here's set B.
But also it has to be
Well, this time I
odd.
want to shade in
So I guess that would just
everything in
be,
A and
alright, what
everything
are all
in
the
B
natural
put
numbers
together.
that are
I'm
odd?
just going to
1,
shade in everything
3,
in A. Here we go.
5, 7,
And then also anything in
9.
this
And if I
that
try to
would
keep listing, I'm never going to
Basically
stop,
just
right?
shading
This is an
in
infinite
set
set,
A,
so I'm going to just
circle
say,
A,
alright, it
and
goes
circle
on,
at
dot,
the
dot,
same
dot.
time.
And if you
That's
didn't
the
end at
union.
9, let's say you
Everything
ended at
goes
7
together,
instead, and then you put the
everything
dot, dot, dot.
Whereas the
That's
intersection
fine. It doesn't really. I
would
guess you
just
just
load
want to
an A
write
and
as
a B at the
many
same time.
elements as convey the
Ah,
idea.
sorry, there's so
Like
many
if I wrote
definitions
1,
here.
3, 5,
Only
7,
two more
and not the
now.
9, I think
The
people would
difference of two
understand that
sets,
it's
if
the
the
odd
set of all
numbers. I don't know
elements
if
in
I need
A
the 9. But I
are
probably
not
wouldn't
in
just
B.
put 1 and 3, because that might not be
Symbolically,
enough
it's
to
kind
tell
of a good
someone it's
actually way
odd
to write
numbers.
it. A minus B.
Anyway, so it doesn't
That
have
kinda
to end
makes
at the
you
same
think, well,
place.
what's an A minus what's
And then
an
how
E?
about part E we got?
What's left over in A
Instead
when
of
you
all
take away
x, such
everything
that
that
x
was
is a
in B?
natural number. Okay, so again, we're only talking
Well,
about
let's
1,
try to
2,
draw
3,
the
4,
Venn
5,
diagram of that.
etc.
We'll start it out the
And
same
x
way.
is,
Here's the
it says it's
universal set.
basically this means it's
Some
between
kind of rectangle. Here's the set A, it's a circle. Here's the set B, it's
15,
another
but notice
circle.
that the inequality
We
next
wanna
to
know
15 has an equal
Basically,
sign.
what's in A
So we're including
that's not in B? I'm not gonna shade in the intersection.
So although
That's
since there's no
also-
equal sign next to
must
the
be
2, I'm not
everything in the
including
circle
2.
A
What's after 2?
except the intersection. So all this stuff over
5.
here.
I'm going to keep listing until I get to 15. 6,
Because
7,
again, that's
8,
everything that's
9,
in A, but not in
10,
B. The
11,
intersection is in B at the same time.
12, 13, 14, 15.
Okay, I'm sorry. Last definition.
There we go. So notice, yeah, 15 is included
The Cartesian
because there was an
product
equal
is two
sign on the
sets, A and
inequality
B.
next to 15.
You know, it
But
seems
2 is
very
not
obvious, but
included
just for the few homework problems you might see it in.
because there was no
It's a
equal
set of
sign
all
on the
ordered
inequality
pairs
next
A,
to
comma
2.
B. That kind of should probably remind you of algebra where you have a
Okay.
point, you know, the point.
Yeah, so hopefully it makes sense so
You
far.
find 1 on the x-axis.
Please let me
two
know
on
if
the
it doesn't make
y-axis.
sense. I know you can't obviously in this video, but
Yeah,
maybe
so it's
email
all
me
a set
or
of all possible
ask me
combinations
somehow.
of
So let's see, example
an
3,
element in A
express
on the
each of the
left and
following
an element
sets
on
in
the
set
right.
builder notation.
So here's an example at the bottom. A.
So this is the
Again,
opposite. They're
symbol
giving
for
us
it is
roster
A with the
notation,
little
and they
X,
want us
kinda
to
like
write
a
set builder.
multiplication symbol.
And there might be multiple ways to write it. As long as the set builder conveys the idea and gives you the right numbers, then you're good.
Is the same thing.
So I feel like in part
Let's
A,
say
it's
your set A
numbers 5 through
contains
12. I can probably kind of
set B
copy the
contains
last
3
part
and
of the
4.
previous problem.
Well, the Cartesian
Now this one,
product
it
was
kind of
just
gave me
all
numbers
possible
between
ordered
blah and
pairs
blah.
that
I
have
can say
either
this is the
1,
set of
2,
all
or
numbers
3
x,
as the
such
first
that,
element,
just like in part E of the last
and then 3
problem,
or 4 as the second element.
x is a natural number.
It doesn't matter
okay.
what order they're in either. Usually what I'll do is I'll kind of fix something
Now
like...
it depends. I guess I
wanna
could
think
say
of
I
what
want
are
it to
all the
be
ways I can
between
write
5
an ordered pair with 3 as
12,
the second number.
including both.
Because 3 is in the set B.
Or you could have said
So I came up
let's
with all
see,
the ways. I
4,
could do
not including
1 from
4,
set A and 3 from set B.
13, you know?
2
So
from
what's
set A
what's
and 3 from
between
set
4 and
B.
13, not including
3
the
was
2?
also in set A.
That would
and
mean
3
the
was
same
in set
thing.
B.
This I think it's more clear
And then I
the
think,
way
well,
I
what else
was
was in
talking
B?
from 5
4
to
was in
12.
B. So the next,
Something like
next
that.
3 I came up with were, what are
So
all the possible
it's
ways
kind of
that 4
difficult,
could be
the
the
set
second
builder
element here?
notation, because you kind of have to
Well, I can
memorize the
have
whole
1
thing.
from set A and
The
4 from
set
set
here
B.
with x, okay,
2
and then the
from set
vertical
A
bar
and
means
4 from
such
set
that.
B.
And if you want
3 from
natural
set A
numbers,
and
you got to
4 from set B.
specify that.
But those are all the possible
Anyway,
ways.
so it's a lot to remember.
And you can kind of
Just
tell which number
try to
goes
bear
where,
in
'cause
mind
if
that,
they say A,
yeah, you have to
cross
write all
B,
these parts to it.
A, that means
X, the
things
bar.
from A are going in the left part of
So let's
that
try
ordered
part
pair,
B. We got
and then
a
things from
set
B are
that
going on the
contains
right of it.
4, 8, 12, 16,
Hopefully
20.
that helps. It's just all the
So
possible
there's probably a few
combinations
ways
of
to say
something
that,
in
but
A
I'm
and
going to
something in
say
B next
it's the
to
set
each
of all
other.
x such that,
Where what's in A has to
again,
be
these
on
are
the left,
natural
what's in
numbers,
B
so
has
these
to
are
be on the
natural
right.
numbers, and
I'm sorry, that's a
I
lot of
don't know,
definitions, huh? But
you can
that's why hopefully we
say
have plenty of
x is a
examples here
multiple
to
of
choose
4,
from.
or x is
See,
divisible
that's
by
kinda
4, that would work too.
So let's just jump in. Example 1 has a set A that pretty much
And then-
contains
oh, you
all
could
the
say, yeah.
natural numbers from 1 to 10. Set B contains
X is
kind of
divisible by
multiples
4.
of
These are
3 up
just
to
two
18.
options. You don't need both.
3, 6, 9, 12, 15, 18.
Just as long as you convey the
And then
right
universal
message, I
set,
guess,
let's
yeah.
say, there should be some kind of set that contains
Alright, how
everything
about
you're
part
talking
C? The
about.
set of
So notice
national
they said
holidays in the United
universal
States
set,
in
it's all the natural
July.
numbers between 1
So that one, I
and
like
20.
that. It's not math, so
And
you could,
definitely
it's probably
everything
easier to
set
wrap
A is
my
in
mind
there,
around.
set B is in there. So
So what kind of
universal set?
national holidays are in
Everything we're
July?
discussing is in that
All I
set.
can think of is Independence Day
The
or
first
4th
thing
of
they want us to
July,
find here is A complement. And remember, from the definition, that's everything
I
that was
apologize
in
if
the
there's one I'm not
universal
thinking
set,
of, but I think that's
which is
the
the
only
numbers 1
one.
through 20. But that was not in A.
I have a hard time remembering in July because it's summertime, right? And it's not like you get a day off from
basically
school
it's missing
because
everything after 10.
school's out.
11,
So.
12,
But I think that's it. Independence Day.
14. You just list them
Hope
out.
I'm not missing one. Please let me know if I am. But I think that's it. That's the only set. Or sorry, that's the only element.
There we go.
So how about
That's
the last
everything
one?
that was
Set
in
of
the universal
even natural
set.
numbers.
You know what you could
Okay.
say, actually, another way to write
I'm going
it.
to try to set it up
Now
like
that we
we
have
did
that
before.
new,
The set of all x such that x
New
is
way
a
to write
natural
it.
number.
Universal set minus A.
So
Remember, that
did we
means
talk about
everything
this yet?
universal
That
set
this
that was
this
not in A.
symbol here, what is it?
And then B
Da-da-da-da,
complement, kind of
means
similar, except we want to know
is
what's in the
an
universal
element.
set, which is the numbers 1 through
So
20.
you know if you're
that
reading
was
from
not
left to
in B.
right,
Actually, there's a
you say
lot. I don't know
x,
if I have room for
and then
this.
that symbol. So x is an
B is
element
missing 1
of
and
whatever
2, It
follows.
has 3,
So the
missing
natural
4 and
number.
5. It has
And
6,
let's see,
but
it's
missing
even.
7
So
and 8.
yeah,
It
just
has
you can
9,
just say
but
that in
it's
words.
missing 10
X
and
is
11.
even. Nothing wrong with
It
that.
has 12, but it's missing 13 and 14.
Okay.
It has 15.
So hopefully
but
you're
it's missing
kind of getting the hang of
16
it.
and
Don't feel
17.
bad if you,
It has
if you're
18,
still
but
not
then it
clear on
turns
set
to 19
builder
and
notation.
20.
It takes a lot of
That's
practice.
as far as I have to go because the universal set
How about
stops at
now
20.
example 4? What do we have here?
So I hope that makes sense.
We got
so
a
far.
graph and it
So
says
that's
use the
kind of
following
concept
graph to
of
write the
set
sets
we
in
have.
roster notation.
What else
Remember
are we
roster
talking about
notation
here?
is the
The
nice
next
one
thing
where
we're
you
trying to
just
find-
list elements.
Remember the upside down
First
means
one, the set of
intersection.
days in which at least
Remember that
8
means
cakes
what's
were
in
sold.
common.
Let's see. What do we have here in this
Common to
graph?
A and B.
Looks like the
Look
vertical
in
is the
the
number
set
of
A
cakes,
and look in the set B
and then
and
the
say, what they have
days
in
of the
common.
week where
Well, 3 is
that
in
number
both
of cakes
sets.
were sold is on the bottom.
6 is in both sets.
Let's see, eight cakes.
9 is in both sets.
What days
Actually,
were,
that's
let's say
about
at
it.
least? Let's say at least.
Besides 3, 6, and 9.
Then I think that
anything else
language
that's
kind of
in
makes
A
it
is
sound
not
like 8 is,
anything that's in B
I don't know,
is
it's
not
part of
A.
a set,
That's
right?
about
You,
it.
like, A day where 8 cakes
And the
were
next
sold
thing we have
is
here
part of
is
the
the
set. You
union.
want
That
to put that
means
in
let me grab
there.
everything that's in
Looks
A
like Monday 8 cakes were
everything
sold. I
that's
want to
in B
write
and put
that.
it together in one
Tuesday
set.
4 cakes were sold, not that one.
And don't really worry about what order they're in.
Looks
As
like
long as
6
you
cakes
list
now.
the same elements, I
So it looks like from there on, Thursday, Friday, Saturday,
So when
Sunday,
I
those
do
all
union,
had
usually
more
what I'll
than
do is I'll just
or
grab
8 or
everything
more
from one
cakes.
set. Let's say
I'm gonna
A,
list
for example.
Monday
A
and
has
then
1,
Thursday
2,
through
3.
Sunday.
So I know I want to put all this stuff
And
together.
don't feel bad if you
What's
abbreviate Monday,
all the way up to 10. Here we go.
Thursday.
So I want everything that was in A, and then I go looking in B and say, what did I miss that I didn't write yet?
Yeah.
B contains 3, but I already listed
How about the
that.
set of days in which less than 10
contains
cakes
6,
were
but I already
sold?
listed that as well.
We'll get a different color to
B
illustrate
contains 9,
this
but I
set.
listed that also.
Less than 10.
But
So
what I'm
here's
missing
10.
is 12, 15.
I guess I can just kind of say,
Those are
where
the
is it
things
cut
that are
off?
in
I want to
B
cut it off
that are
right
not
here
in
at
A.
10.
But yeah,
Looks like
notice even
Thursday,
though
no,
3
because
was in both
Thursday
sets, I
had
didn't
more cakes
bother
than 10,
listing
but
it
every
twice.
other
As long
day
as it's
before
listed
that,
once, you don't
Monday
have to
through
list it
Wednesday,
twice.
had less cakes than 10. Monday was
About
8,
halfway
looks
through
like
this problem. That's
Tuesday
pretty
was
good.
4,
And I think, yeah, the
and then
difficult part is
Wednesday was,
remembering
what
what all
did
these
we say?
symbols mean, really.
6?
It's
Yeah.
not the problems itself.
So it'd be Monday, Tuesday, Wednesday
Let's
for
see,
that
they
one.
want A minus B. Well, what is basically, yeah, again, what's in A that's not in B?
There we go. Alright, I think we're doing good here.
It's in
Oh, sorry,
A,
what's part C though?
but not in B.
A set of days
Let's
in
look
which the
A.
number of
What's in A? We
cakes
got
was sold
1,
was
well,
between
that's not
6
in
and
B, so I'm going to list
16.
that. 2, that's also
Okay,
not
that's
in
kind
B.
of more
3, well,
thought
that
goes
is
into that.
in B. I'm not going to list that. 4
Where's
is not in
6? 6
B.
cakes
5
is
is not in
here.
B.
16 is up
6
here,
is,
so
so
I
I'm not
want,
gonna list that.
basically, where is it in this
7
range
and 8
here?
are not in B.
From this
9
guy
is,
to
right?
this
Wait,
guy.
yeah, 9 is, but 10 is not. There we go.
Looks
That's
like Monday
everything
was in that
that's
range,
in
huh?
A, but not
Monday,
in B.
Tuesday, no, because it was less than 6.
And the next part, they want us to flip it
Wednesday
around.
was exactly
What's
6.
in
Does
B
it
that's
sound like
not
from the
in A?
language 6 is okay?
So what's in B there? We got
You know they
3,
said
that's in
between
A,
6
so I
and
don't list
16.
that.
That kind of makes it sound like
6 is
6
in
is
A
not
also, I'm
included,
not
right?
listing that.
Between,
9 is
yeah,
in
that
A.
would feel like that
But
makes it
after
sound like
9, everything else is not
anything
in A.
between is
12,
okay, but not 6 and not 16. I think I'm not going to include, what was it,
Alright,
Wednesday.
good stuff.
A Monday so far, not Tuesday, not
We have
Wednesday.
here.
Thursday, yes, because Thursday was
Next thing we're
12
asked to
cakes.
find- This is kind of a complicated
Friday was, what's that, 15
No.
cakes. So that
It's
would
the
be included.
complement of
But
A,
Saturday
B,
and
B.
Sunday were above 16,
Remember,
so I'm only going to
complement is what's
include
not in
Monday,
this thing.
Thursday, and
What?
Friday. That'll be that set. Let's see.
Not-
Better not try to write with the highlighter. That doesn't make sense. What would say
That is a
Monday?
universal set. Thursday. So in other words, it's a universal set. Mine is A union B.
All right. Last,
So the
last
good thing
part
is
of
I already
this
found
problem.
A
Then we can
union
move on to the
B
next
up
one.
here. Where is he?
So what do we have?
In
The set
green
of
over
days
here. So I'm going to kind
in
of
which
refer to
the
this
number
guy right here
of
that I'm drawing the star next
cakes
to.
sold was more than
So I
20.
just have to look in A union B
All right, I
as the
think
set that
that
I
one I
wrote.
had kind of know
What's
because I was looking at the
not
graph
earthly?
just
See,
now.
what's in the universal
More
set
than
that's not
20.
in
Here it
A?
is. 20.
What is A union B?
One is the
missing?
graph
Well,
above
it has
20,
the numbers
never.
1 through
It's never above 20, right? So I would say
10, right?
it's the empty set.
Yeah,
There are no
numbers 1
days
through
in
10,
the week
so
that we're talking
I don't
about
have to worry about
where
that, but
they
it
were
doesn't
sold more
contain
than
11.
20 cakes. Maybe in a different week, but not on this graph anyway. I
Remember,
don't
the
see that.
universal set is the set just from 1 to 20.
All right, so far so
It
good. Let's
has
see here.
12, so I don't need to list that, but it's missing.
Now they want us
13,
to, in this
14,
problem, determine whether
It
each
has
statement is true or
15.
false.
but it doesn't have 16.
Okay, and this one just kind of
17.
using all the,
It has 18, but
I
it
guess
does
all the
not
symbols
have
that we've been
19
talking
and
about.
20.
So here it says,
All right,
oh, this
I
is kind of a
think
tricky
here
one
we've
actually.
written
Part
What we were
A
looking for. What's in
is the set with X in it, an
what's in
element
the universal
of
set that's not in A
this
union
set,
B?
U, V, W,
And I already
X,
had
Y,
A
Z.
union B to keep looking at.
So that's actually a tough one. It seems like yes, X
And the
is
last
an
thing
element
we
of
wanted
that,
to find
but
is what's in the complement of
X
A intersects
with
the
those
complement
brackets
of B.
around it is a set.
And the good thing is, you know,
It's not an element.
if I hadn't done the previous
A
part, I
set
might actually figure out what's in
Can't
the
be
complement of A.
an
I could actually do
element
this out right here. We already did the complement of A, but
of
if I
another
hadn't done
set.
it, I'd probably list it out to make this part easier.
Set, so it's a no.
And then also the complement
sorry,
of B.
false.
Where's that guy?
That one's a tricky
Next
one.
one.
So if this, basically if this
Complement of
X
B is this
didn't
set
have the brackets
here.
around it, it would be true,
But now
because
that
it
I
just
have it
means
listed
X,
out
the element.
explicitly, I can figure out
Because the
intersection.
brackets are around it, it's a set. And a set can't be an
Remember-
element of
remember the
another
intersection
set.
means
It's only
what's in both
individual
sets.
elements. So
What
it's kind of tricky.
in the complement of A and in the
How
complement
about part
of B.
B?
at
I'm
the
not
same
sure
time.
what's
So
going
just
on
have
here. I think,
those two
sorry, I think I
top
messed
sets
up.
that I highlighted.
The set, let's see, A is the
yellow
empty
and the
set.
green.
I guess,
What's
I
in
mean,
both of
there
those
might
at
have
the
been more
same
to it, but I'd say
time?
true, because, I don't know,
11.
empty
Oh,
set,
yeah, I
what's
think
wrong with
11's
that?
in both.
Maybe I think I have to add more, I'm sorry. I think I missed something in that problem. Let's see. see. I'm gonna add.
13 and
where are
14
we?
are. What else?
Yeah, let's see.
No,
Let's add
13 's not in
A.
decomposition. About 16, 17, yes.
Oh no, let's add.
What else is there? 19, 20? Yep, 19,
X
20.
is an element of
I just listed all the things that are in this, the
We'll make that
highlighted
first.
yellow set and the highlighted green set. That's what they have
So
in
it says
common.
A is the empty set, but X is an element of A. So does that sound right?
Okay.
I'd say
Right now that was a
no.
lot of symbols to try to keep track of, but
Because A has nothing in it. It's empty. So how can X be an
and
element
then
of
once
A?
you practice your own, I think it'll make it a lot easier. Empty. Let's see. So example 2, construct the Venn diagram for the
X
following
can't be an
sets.
element.
Try part A. Part A, yeah, and since it's explicitly listed here, like A has these elements, B
Sorry
has these
about that.
elements,
How
it's
about
hard to
part
think of how
C
to draw
here?
that. But I think once you
This
see
is
an
saying
example,
M
it makes sense.
is an element of this set
Like
with
I said,
mu
we
v
start out with the
w x
rectangle,
y
here's
z
the
in it.
universal set.
That one's false. for
Even though they
different
haven't said what's in the universal
So
set.
false. Sorry, M. I don't see M in that set, so it'd be a no. But if this was one of the letters that's actually in the set, like if that was a U or a V or one of the other guys, it'd be
Do they
true.
intersect or not?
So notice part A, because it had the squiggly brackets around X, that's a no, because that means it's a set. But this just has a letter itself with no brackets around it, so it could be possible to be true, but that letter M is not in the set, so I'd say it's false. Just because that letter's not in the set.
The number 1 is in A, but
How about part D? This is kind of a weird one. The element we're talking about is Peter Pan. Is Peter Pan an element of the set of Disney characters? I'd say that's true. I mean, I think so, right?
Number 3 is in the set A, but it's not in the set B, so I should draw that somewhere in set A.
Disney character.
Not part of the intersection.
I mean, I think.
And then the number 4 is
I'm not sure if it was originally a Disney character or someone else made it up, but definitely it's one of the characters in the movies.
What else is in A?
How about part E? Is 9 an element of this set? 1, 3, 5, on and on and on and on.
Part of the intersection.
That one, it just looks like it's the odd
B,
numbers.
okay, what have I not used yet? I already drew the 2.
The natural
the
odd numbers,
intersection.
you know.
I drew the 4.
And 9 is an odd number, so
6
I'd
I
say
haven't
that's true.
written yet.
Even though I don't see
Since
9
6 is
listed
not
because the
in
dot dot
A,
dot goes
I'm
on
gonna write
and
it
on.
over on the
I
right
mean,
side
it's
where
going
I
on
don't
and
wanna
there are
put it
numbers
as
that
part of
are
the
not
intersection.
listed. But you can kind of get the
Because
idea of what's
that
in
would mean
there.
it's in both sets A and B. And the same with 8.
How about
It is
part
not
F
in the
here?
set A, so
Bugs
it should go
Bunny.
outside-
And this might be
outside the circle of A, but
before your
inside
time,
the
but Bugs Bunny was a character from Looney
I think that's
Tunes.
pretty much it. There's
So
nothing
kind
that
of
I know of that's outside A and B. They didn't give us any extra information.
Yeah, whatever.
Alright,
It's
let's
a
try
character in
this
Looney
part here.
Tunes.
This one's going to be
And Looney
more
Tunes and Disney are not
complicated.
affiliated, so this would be
Set
false.
A, set B, set C. Maybe I'll
Bugs
draw
Bunny
three
is not a
all
Disney character.
Yeah, since there are 3 sets here,
The
I
last
have not
part,
only
how
the
about part
universal
G?
set that's outside. I'm gonna
Part
have
G
3
says,
sets
notice that
inside.
this,
Set A,
the E or this little
draw
E
a
that
circle.
usually says element of
I'm
has a
gonna
line
draw
through it.
set B.
I don't know if we've talked
I'm
about
going to
this
see
yet,
if
but that
it
means
has anything in common with set A.
it is not.
They
When
have
you see
nothing
a
in common,
line,
I'm going to draw
there's
them so
something
that
that
they have
means
no
is not,
intersection
whatever it
overlap.
usually.
But there is something in set A and set B by yellow. Okay, since they have something in
So
common,
X is not an element of that set. That would be false. Because X
And
is an
then
element
set
of
C, I'm
that
going to draw
set.
another circle.
So if this
But I
symbol
wanna
did
see
not
if it
have a line
overlaps
through
with
it,
A
it would be
or B.
true, because that means
C have
X is an
anything in
element
common
of.
with A? Yeah.
But they're trying to say
Orange
X is not
both
in
A
the
and
set,
C.
but it is. It's
So
clearly
there
in
could
the
be some kind
set,
of
so I'd say
overlap
that's false.
between A and C. How about B and C? Do they have anything in common? Yeah.
Alright, last
blue
example. It's
and
kind of
orange,
sad, but
actually,
true.
so- Okay.
It says determine,
Intersect both of those
I guess
sets.
this is the cardinality, right? We said
And
cardinal
this is
number.
definitely more complicated, but let's see. Keep in mind. Well, let's just go for it.
Remember that just
I
means
think
number of
so
elements in a
overwhelming, I'm just
set.
going to go look at set A and start writing stuff. So red. First thing in set A is red. I want to draw
These are
that
probably the easiest
somewhere.
problems in the section, which is nice.
Or sorry, I want to
Why
write
does
that
it
word
count?
somewhere,
How many
but I want
elements
to
are
see
in
is it
set A?
in either of the other
1,
sets.
2, 3,
No, I'll notice that
5,
the word red is in set A, but it's not in B or C.
6.
I'm going to write the word
That's
red
the number of elements in A is
in the
6.
circle of A, but it better not be part of
So how
the
about
circle
here?
of B or
A
C.
is the set of all X in
I've
part
done
B,
that one. Sometimes I
such that X is a state in the United States.
What else is in A?
Well, that one I don't really need to count. I think I just know that there are 50 states in the United
Yes,
States.
it's also in B, so it should be part of the intersection. But notice that orange is also in C. That's a word that's in all 3 sets. So what part of this
Sometimes you get
diagram
lucky and you don't have
is
to
in all
count. You
3
can
sets?
just,
It's
I
very
don't know, from
inner
prior
part
knowledge,
here.
you could just figure it out.
I'm going to draw orange
In
right
part
in the
C, we
middle.
have the empty
Notice that
set.
that's in the circle
So
A.
I would
it's in
say the number of
circle B.
elements,
It's
I was
also
going
in
to say
the
number of
circle
elements
C.
in A.
Anywhere
You're
else
right.
within,
A.
outside of that
Number of
little,
elements in
I don't know, that
empty
little
set
triangle kind of
is
shape
0. There's nothing
would
in
not be
there.
in all 3 of them.
So the only time the
I got
cardinal
orange in
number
the
or the
right place. What about
cardinality
yellow?
will be 0
Yellow is in set
is
A,
if
so it's
you're talking about the
definitely
empty
gonna be in the
set.
red
Any
circle.
other set should have either
also in
1,
set
2,
B.
3, 4,
So it'll
on
be a
and on
green
number
circle
of
to go
elements.
through.
It's just the empty set that
But
would have
notice yellow
0.
is not in set C.
How about
So it should
part
go
D, the number
here,
of
and I'm
elements
writing
in
the
this
word
set?
yellow. That's
has
because
1, 3,
that's the
5,
portion
looks
that's
like all the
part of
odd
A and B,
numbers.
but it's not part of C.
So since it's the
Okay,
dot
I
dot
think I've
dot,
got yellow down,
that's
how about
infinite,
green?
so I'd say
Green is in
the
set
cardinal
A,
number
so
is
it'll be in the
infinity.
red circle.
so
Green is,
for that
actually
one,
notice it's not in set B or set C. So I'm going to draw it,
it's
or
infinite.
sorry, write it. That's
I guess my reason
in the
why
set
I would
of
say
circle A, but not in set B or C.
Okay, so this section's kind of
I think
silly,
I've
right?
got
It's kind
everything
of
in
just the
set A
beginning of
down.
chapter
Look at
2.
set B.
Just
First thing
kind of
in B
setting the
is
stage
yellow,
for
but
more
I've already
interesting
drawn
things to
yellow.
come.
Done.
So sorry,
The
it's
next
kind of
thing is
boring,
orange. I've
but
already
thanks for
written that
bearing
as
through
well.
it with me.
Blue is the only thing I'm missing.
See you in the next
Let's
video.
see, blue. Okay, I could write it somewhere in set B, but I think what
Hey everyone, this is
that
Kirk
also-
here again at optionalpha.com to be successful in this business.
We got blue, we got
So if you
orange.
don't get the math behind the trades, here's my promise to you. You will fail at trading options long term if you don't understand the math behind it, and more importantly, the statistics and the probabilities behind it. You can make a couple trades here and there and be successful, but to do this long term, to generate consistent monthly income long term, you've got to understand the math. So swallow your pride, head back to school with us as we talk in depth about standard deviations, probabilities, and statistics in this advanced tutorial. But before we do that, let's first have a talk about one real quick thing, and that's market efficiency. So this whole idea about market efficiency is really important, and you've probably heard us talk about in other videos that we have to trade liquid products and liquid underlying stocks. But this whole idea of market efficiency is this concept that the markets are super efficient, and especially in the US markets where there are millions and millions of different market participants, all with their own individual ideas. The markets are incredibly efficient and incredibly fast. Data or information that anybody receives on a stock or a company is immediately priced into the market. And as a guy who's been on both sides of the Chinese wall, basically I was a M&A analyst in New York for Deutsche Bank, and so I was on the private side dealing with mergers and acquisitions. And then I was on the other side of the Chinese wall in Tyson's in DC and dealing with the retail side as an analyst. So I've been on both sides of the wall, and I can definitely tell you the markets are incredibly efficient. There's no edge that you can get in knowing information about a company in advance or having some sort of insider knowledge. In most cases, most CEOs have no clue where their stock is going to go or how it's going to react to the market, regardless of how well they think they might be doing. So to that end, we have to understand that, as we said before, we have no clue where a stock is going to go, and nobody else does either, myself included. I have no idea where a stock is going to go in the future. I might have an assumption, an opinion, but at the end of the day, we're all no better than 50-50 on our guesses. So what this leads to then is to this probability distribution, and what we call a normal distribution, or what you probably have seen before as a bell curve. Now this is really important because this is how distributed, or this is how a efficient market distributes its returns. So basically what you have here is you have most of the returns are probably, somewhere around even or par, and that's basically what this kind of zero line here is. But it's saying that most of the time, the distribution of returns will be within a certain confidence range, or within about a 1 standard deviation. This did it one time, how often are you going to win, right? If you only did it one time or 2 times, heck, even 10 times. You only did a trade 10 times a year. How often are you really going to win? How often are 10 trades actually going to work out in your favor? Right? So it doesn't work. You take one of these building blocks away, and the whole thing crumbles. And this is what most people miss in this space, in my opinion, is they do 1 or 2 or 3 of these, but they don't do all of them. So let's dig in a little bit deeper here and start talking about trade size. Now this is something we've covered before in depth, but again, at Option Alpha, we firmly believe, and I've believed this for a long time, that your trade size should be no more than 1 to 5% of your account balance. Okay, so if this is your account balance on the left-hand side, meaning how much capital you have in your account, this should be your sliding scale of trade allocation size. Now, obviously, in my opinion, I think most of the time you should play in this sandbox, meaning the 1 to 2% region. Even at a $250,000 account, which is a large account, 1% is $2,500 of risk per trade. You can do a lot with $2,500 of risk per trade. You don't need to be going up to the $12,000 of risk per trade. But that also means that if you have a small account, so say you're trading under $5,000, you may need to, kind of increase your position size because of the small account so that you can get some trades across, right? So you may need to move up to the 2 or 3% level. But there are definitely trades that you can place out there for $100 or $150 risk. Are you going to make enough money to, quit your job and, sail away on a cruise ship or yacht or whatever? No, you're not. But you have to be realistic with your expectations. And if you trade too large with a small account, don't make the assumption that making or having more money in your account is going to magically make you a better trader. I can guarantee that if you can't make money with a account $15,000 to $5,000, there's no way that you're going to make money if you had an account of $100,000. You're just going to lose money a lot quicker with more money. Okay, so focus your time, if you do have a small account, focus your time on making small, high probability trades like we're going to discuss, because that's how you win in this game. It's a long-term game of slowly building up capital and profits, okay? Now, obviously, the next part of that is high probability of success. And this is something that we've talked about, again, ad nausea, because we know what the probabilities of winning on a trade or not are or not. And we can show you here in a second. But remember, markets move in a more or less normal distribution pattern. We actually showed in one of the previous videos here in track 1, we went back all the way to 1990 and tracked the Dow Jones daily move, and it was almost exactly a normal distribution from 1990. Are there times when you'll have 5 or 6 days of up moves? Yes, but generally over time, markets move in a normal distribution pattern of percentage up or percentage down moves. So if we take that normal distribution pattern, we know that over time, as the stock moves, we can figure out what likelihood or what the percentage range is that the stock might move 68% of the time. So like we could take this stock, and if this stock was at $50, we could look on our charts and on our broker platform and see that there's a 68% chance it moves between $60 and say $40. Okay, so we know those are known numbers. And this is how we can then determine what types of high probability trades we want to get into. Okay, and then at that point it just is a matter of choosing which direction you want to go, and it really doesn't matter at that point. Okay, so here's the deal. So here's a high probability example of a trade that you can make in, I think the chart that I grabbed here was SPY. Okay, so SPY at the time that I grabbed this chart was trading at 203. The April options, which are about 22 days away, you can see exactly what the probability of each and every strike price being in the money is at expiration. Now remember, this is calculating based on the entire trading history of the S&P or whatever stock you're looking at, every move it's ever made, up or down, the magnitude of every move, how fast it's moved in a given time period, and then implied volatility. And so all of those numbers are then populated into a broker platform where you can see what the probability that the stock is, that each and every strike is going to be in the money at expiration. So in this case, if the stock right now is trading at 203, we know that in the next 22 days, there is a 31% chance that the stock goes from 203 up to and above the 205 and a half call strike. We know that that's the probability. So if there's a 31% chance that it goes above that level, that means that there is basically a 70% chance that it never goes above that level. Okay? So if we're option sellers, which we usually like to be, then we would sell these 205 and a half calls and basically taking a credit of $152, knowing that we've got about a 70% chance that the stock never gets to our strike price. Okay, so again, these numbers are known, and you can basically pick what likelihood of success you want to have. I mean, the field is open. You know what I mean? The buffet is open. You choose how often you want to be successful. At Option Alpha, we usually choose around the 70% probability of success range. Okay, now it works in the same direction, in the same way, in the opposite direction with puts. So down below the market, we also know that if the stock is trading at 203.20, that in the next 22 days, there is only a 30% chance that the market goes below 198.5. Okay, so again, we know these numbers. They're known numbers. That means that if the stock market doesn't go, or there's a 70% chance that the stock market doesn't go below 198.5. Okay, so 70% chance that it stays above this level at any point between now and expiration. So again, if we were to sell these put options, we could sell these put options for $122 and have basically a 70% chance of success. Okay, so notice, it really doesn't matter. I mean, like, there's a slight difference in pricing here, and in most cases there's going to be a slight difference in either direction, one way or another. But generally speaking, you're collecting about the same amount of money for the same probability of success on either end. So really, direction is meaningless compared to making high probability trades and being on the right side of volatility. Okay? So again, we got more video tutorials on that here at Option Alpha. We don't have time to go into every possible strategy and how you can figure out the probability of success, but this is a great example because I just wanted to show you guys that it's known. You can choose your probability of success, however successful you want to be in the trades that you make. Again, here at Option Alpha, we choose about the 70% level. We find that that's a good risk reward for what we try to do. Next, it's important we focus on just stocks and ETFs with really great liquidity, because slippage can literally rob you of your potential profits. Now, here's the deal. Here is SPY. And this is not the time that I did the other screenshot here, although it's very similar pricing, but completely different time. So that tells you the market's been completely sideways since then. That's pretty interesting. But when I took this screenshot of slippage, it's important to note that SPY is one of the most highly traded ETFs and options that are out there. And you can see the volume and open interest category for both the calls and the put side here is insane, right? There's a lot of people who are trading these options. And as a result, the options have very, very narrow slippage or very tight bid-ask spreads. You can see even far out of the money, around 201.5 and even at 204.5, the slippage is down to around a penny or 2 pennies per trade. Okay, so very, very tight slippage. Apple, another great example. Highly liquid stock, highly liquid options. Look how many people are trading the volume and open interest for each of these contracts in Apple. I mean, it's just, there's a lot of liquidity in these markets, and what that means is that there's very minimal slippage. So there's not a lot of slippage in the difference between what you can buy an option for and what you can sell it for, the bid-ask spread, okay? Now, even with these incredibly tight bid-ask spreads, we'll still lose a little bit of money to slippage trading options, again, in these super liquid options. So here's how the math works out. If you have an option that has a $1 or 1 penny wide bid-ask spread, you times that penny, because I want to get you to the full value here, you times that penny by 100, which is the contract multiplier. Because remember, each option contract controls basically 100 shares of stock. So 1 penny times 100 times 1 contract, if you just buy 1 contract, times 2 sides to every trade, meaning you're going to basically lose this slippage if you as soon as you get into a trade and as soon as you get out of a trade. Because most people don't cover that part of it. They only assume slippage happens once and then it's done, but you lose it twice effectively. So you lose that slippage twice. That means that every time you trade just one option in Apple or SPY, you're losing $2 per trade. So again, every single time that we trade Apple, just one contract, you lose $2. If we traded each stock 1 time each month for a year, we'd lose $48 just in slippage. Okay, that's little slippage. That's minimal slippage, the least amount of slippage you can possibly have. But let's not deter you. The profits we can generate, again, just trading one spread each time, covers slippage and commissions each year. But what about other stocks? And this is the important part here about choosing liquid underlying stocks and options. So here's an example of Nike. Nike is kind of middle of the road. It's got, I wouldn't consider this to be insanely high slippage. I think there's things that are even wider than this, 50 cents to $1 wide. But Nike is not necessarily a very liquid underlying. Okay, so in this case, you can see that Nike, the slippage, even for at-the-money options, is pretty wide. I mean, we're talking about 10 to 12 cents wide of slippage between the bid price and the ask price. And again, it's reflective in the fact that there's not a lot of volume and open interest for these contracts generally. There's a couple people trading, and that's okay, but there's not a lot of volume and open interest for Nike contracts right at the time. So here's how the math works out on Nike. You've got a $10, let's take the lower end of that range, a $10 bid and ask spread, times the 100 contract multiplier, times 1 contract if you just get into 1 contract, 2 sides because you got to open and close it. That means $20 per trade you're losing just in slippage. Now, we didn't even talk about commissions. So again, every single time that you trade just 1 contract in Nike, we're losing $20 to slippage. We talk about starting out in the hole, right? I mean, you get into a trade, you're down $20 immediately. And you wonder why most traders don't make money in this business. So again, if we traded Nike just 1 time each month for an entire year, we would lose $240 in total. That's 1 stock in 12 trades. Again, you wonder why people don't make money in this business, because they're not focusing on highly liquid underlyings, okay? Now, thankfully for you guys, we did build a watch list here at Option Alpha that pre-screens all of the possible stocks and ETFs out there for liquidity. We update this list on a rolling basis to make sure that these options and stocks both have a lot of liquidity and fairly tight bid-ask spreads, okay? So we focus here on Option Alpha at around, probably around 80 to 100 stocks and ETFs, depending on how we screen them out. And we built this watch list software into our platform. It's totally proprietary for us that we built. And again, it's really cool because now you can focus, I just want to focus on, let's say, ETFs only, okay? And now you can scan and filter between ETFs or earnings trades. You can say, hey, I want to see the highest implied volatility stocks first or the lowest implied volatility stocks first. Whatever you want to do, it's all pre-built into this platform. And again, we don't give you the ability to search for any stock here because we've already scanned the entire universe and we've basically chosen the top 80 to 100 depending on the month cycle that we're in, because we'll constantly update and monitor this. But we've basically given you the list of 80 to 100 of the most liquid